Welcome back to AI Pulse Trends, where we explore the cutting-edge applications of artificial intelligence that are reshaping our world. Today we're diving deep into one of the most promising intersections of technology and humanity's greatest challenge: AI's role in tackling climate change and advancing sustainability. The climate crisis represents the defining challenge of our generation. Rising temperatures, extreme weather events, biodiversity loss, and resource depletion threaten our planet's delicate balance. As we race against time to reduce emissions and build resilience, artificial intelligence has emerged as a powerful ally in this battle. But before we dive into the transformative applications of AI in climate action, let's understand why this technological revolution matters so profoundly in the environmental context. The scale and complexity of climate change require solutions that can process vast amounts of data, identify patterns invisible to human perception, optimize complex systems, and accelerate innovation across sectors. This is precisely where AI's capabilities shine brightest. According to the World Economic Forum, AI applications could reduce global greenhouse gas emissions by up to 4% by 2030, equivalent to the annual emissions of Australia, Canada, and Japan combined. From optimizing energy grids to revolutionizing agricultural practices, AI is helping us reimagine our relationship with the planet. However, this green AI revolution isn't without its challenges. The carbon footprint of training large AI models, concerns about technological equity, and the need for ethical frameworks all demand our attention. As we explore AI's environmental applications today, we'll confront these tensions head-on. Our journey will take us across 5 critical domains where AI is making its mark on sustainability. First, we'll explore how AI is transforming climate science itself, enhancing our ability to model complex climate systems, predict extreme weather events, and track carbon emissions with unprecedented precision. Next, we'll examine AI's role in revolutionizing energy systems, from optimizing renewable energy forecasting to creating intelligent grids that balance supply and demand with minimal waste. Third, we'll investigate how machine learning algorithms are helping us protect and restore ecosystems, monitoring biodiversity, combating deforestation, and even accelerating coral reef preservation efforts. Fourth, we'll see how AI is redefining sustainable cities and infrastructure, optimizing transportation networks, reducing building energy consumption, and creating more livable urban environments. Finally, we'll look at how AI is empowering sustainable business practices and circular economy models, from transforming supply chains to reducing waste and resource consumption. Throughout our exploration, we'll showcase real-world examples, groundbreaking innovations, and the brilliant minds behind these technological solutions. We'll hear from climate scientists leveraging AI to improve climate models, engineers designing the next generation of smart grids, conservationists using machine learning to protect endangered species, and entrepreneurs whose AI-powered startups are redefining sustainability. By the end of this journey, you'll have a comprehensive understanding of how AI is being deployed in the fight against climate change, the potential limitations and ethical considerations of these applications, and what the future might hold for this powerful technological alliance. Whether you're a climate activist seeking new tools, a technologist interested in sustainability applications, or simply someone concerned about our planet's future, this episode will equip you with insights into one of the most promising frontiers in both environmental science and artificial intelligence. So join me as we explore how the computational power of AI is being harnessed to secure a more sustainable future for our planet. This is AI Pulse Trends, and we're diving into AI in climate change and sustainability. AI revolutionizing climate science. Climate science deals with some of the most complex systems on Earth: the interaction of our atmosphere, oceans, land surfaces, ice sheets, and the biosphere. Traditional climate models, while increasingly sophisticated, still face limitations in resolution, accuracy, and computational efficiency. This is where AI is proving transformative. Machine learning algorithms are enhancing climate models by identifying patterns in vast datasets that might escape human analysts. At Google's DeepMind, researchers have developed AI systems that can predict extreme weather events with unprecedented accuracy. Their deep learning models can forecast floods up to 5-7 days in advance, giving communities crucial time to prepare and potentially saving thousands of lives. Similarly, Climate Change AI, a nonprofit initiative of leading researchers, has developed neural network architectures that improve the spatial resolution of climate models, without requiring the massive computational resources traditionally needed. This democratizes access to high-quality climate projections for regions that may lack supercomputing capabilities. Perhaps one of the most impressive applications is in carbon monitoring. Satellites equipped with AI-powered imaging systems can now detect and measure emissions with pinpoint accuracy. The Climate Trace Coalition utilizes machine learning algorithms to analyze satellite imagery and sensor data, creating the world's most detailed inventory of greenhouse gas emissions across 241 countries and territories. This breakthrough enables real-time emissions monitoring at the facility level, something previously impossible with traditional reporting methods that often relied on self-disclosed estimates. Dr. Priya Danti, co-founder of Climate Change AI, explains, "What makes these AI applications so powerful is their ability to extract insights from complex, multimodal data, satellite imagery, weather station readings, ocean buoy measurements, and integrate them into more comprehensive understanding of our climate system." However, researchers are careful to note that AI supplements rather than replaces physics-based climate models. The most effective approaches combine traditional climate science with machine learning, creating hybrid models that leverage the strengths of both paradigms. AI transforming energy systems. The transition to renewable energy is critical for mitigating climate change, but integrating intermittent sources like solar and wind presents significant challenges for power grids designed around centralized, predictable generation. AI is helping overcome these hurdles. At the forefront is forecasting renewable energy production. Google's DeepMind has applied machine learning to predict wind power output 36 hours ahead, with approximately 40% greater accuracy than conventional methods. This enables grid operators to better plan for fluctuations and reduce the need for fossil fuel backup generation. For solar energy, Stanford researchers have developed deep learning algorithms that analyze weather patterns, historical production data, and satellite imagery to forecast solar generation with unprecedented precision. These forecasts help grid operators seamlessly integrate solar power even during partly cloudy days when production can rapidly fluctuate. Beyond forecasting, AI is revolutionizing how energy grids operate. Smart grids equipped with AI can balance supply and demand in real time, automatically rerouting power to where it's needed most and reducing wastage. In Germany, the company Grokero uses reinforcement learning algorithms to create virtual power plants, networks of distributed energy resources like rooftop solar panels, batteries, and electric vehicles that function collectively as if they were a single power station. The beauty of AI in energy systems is that it can optimize for multiple objectives simultaneously, explains Dr. Emma Williams, energy systems researcher at Imperial College London. We can program these systems to minimize carbon emissions while also ensuring grid stability and keeping costs affordable for consumers. On the demand side, AI is dramatically improving energy efficiency. Google's DeepMind reduced the energy used for cooling its data centers by 40% by applying machine learning to optimize cooling systems. Similar approaches are being implemented in commercial buildings, which account for roughly 40% of global energy consumption. Particularly promising is the use of AI for designing new energy materials. At the Material Acceleration Platform, researchers use machine learning to screen thousands of potential materials for solar cells, batteries, and catalysts, dramatically speeding up the discovery process. This computational approach has already led to breakthroughs in next-generation battery technologies that could make renewable energy storage more affordable and efficient. Protecting ecosystems with machine learning biodiversity loss represents another planetary emergency, with species extinction rates estimated at 1,000 times higher than pre-human levels. AI is emerging as a powerful tool for monitoring and protecting ecosystems. In the Amazon rainforest, Rainforest Connection uses machine learning algorithms to analyze audio data from repurposed smartphones placed in trees. These devices can detect the sounds of illegal logging, like chainsaws or trucks, and alert authorities in real time. The system can distinguish these sounds from background noise with over 95% accuracy, even in dense forest environments. For wildlife conservation, AI-powered camera traps are revolutionizing how researchers monitor endangered species. Organizations like WildMe have developed computer vision systems that can identify individual animals from their unique markings, creating a digital fingerprint for each creature. This enables non-invasive population tracking and has already been successfully deployed to monitor whale sharks, zebras, and jaguars. Marine ecosystems benefit similarly from AI innovations. The Australian Institute of Marine Science uses autonomous underwater vehicles equipped with computer vision systems to monitor coral reef health. These AI systems can assess coral bleaching, identify crown-of-thorns starfish, a coral predator, and track recovery after extreme weather events, covering in days what would take human divers months to survey. Meanwhile, Microsoft's AI for Earth program partners with conservation organizations to apply machine learning to environmental challenges. One project uses satellite imagery and deep learning to map forest cover changes across millions of hectares, providing conservationists with nearly real-time information about deforestation. What's particularly valuable about AI in conservation is that it scales our monitoring capabilities exponentially, says Dr. Lucas Martinez, conservation technologist. We can now watch over vast ecosystems with a level of detail that was previously impossible, intervening precisely where and when protection efforts are most needed. Even in agriculture, AI is helping reduce environmental impacts. Precision agriculture platforms use computer vision and machine learning to analyze drone and satellite imagery, enabling farmers to apply water, fertilizers, and pesticides only where needed. This approach can reduce chemical use by up to 90% while maintaining or even improving yields. Building sustainable cities and infrastructure. By 2050, nearly 70% of the world's population will live in urban areas. Making these cities sustainable is crucial for addressing climate change, and AI is playing an increasingly central role in this transformation. Transportation represents a significant source of urban emissions. Companies like Waymo and Cruise are developing autonomous vehicle technologies that could reduce emissions through more efficient driving patterns and enable shared mobility models. Meanwhile, cities like Singapore and Pittsburgh are implementing AI-powered traffic management systems that dynamically adjust signal timing based on real-time conditions, reducing congestion and associated emissions by up to 25%. In building management, AI systems are dramatically cutting energy use. Sidewalk Labs has developed an AI platform that learns from occupancy patterns and weather forecasts to optimize HVAC systems in commercial buildings, reducing energy use by up to 40%. Similarly, companies like Brainbox AI use deep learning to create self-adapting building management systems that anticipate and respond to changing conditions without human intervention. Urban planning itself is being transformed by AI's analytical capabilities. Barcelona's Superblocks initiative uses machine learning algorithms to model traffic patterns and air quality impacts when redesigning neighborhoods to prioritize pedestrians and cyclists. The resulting designs have reduced air pollution by 25% in pilot areas while creating more livable community spaces. Water management represents another critical domain. In drought-prone South Africa, the company Drupal uses AI to detect leaks in municipal water systems, reducing water loss by up to 30%. Meanwhile, Copenhagen's comprehensive flood protection system uses AI to analyze weather data and water levels, automatically activating pumps and barriers to protect vulnerable neighborhoods during heavy rainfall events. Perhaps most promising is AI's application in circular economy systems within cities. In Amsterdam, the AI-powered AMS Institute uses computer vision to analyze waste streams, enabling more effective sorting and higher recycling rates. The system can identify recyclable materials with over 95% accuracy, significantly reducing landfill waste. The power of AI in urban sustainability comes from integration, explains urban planner Sofia Mendes. When we connect transportation systems with energy grids, waste management with material flows, and buildings with weather patterns, we create intelligent systems that optimize resource use across the entire urban ecosystem, enabling sustainable business practices. The business sector's embrace of AI for sustainability represents one of the most promising developments in corporate environmental responsibility. Supply chain optimization offers particularly impactful opportunities. Walmart has implemented machine learning systems that analyze inventory, transportation routes, and energy usage across its massive supply chain, reducing CO2 emissions by millions of tons annually. The system optimizes not just for cost, but also for environmental impact, finding synergies that benefit both the bottom line and the planet. In manufacturing, predictive maintenance powered by AI is extending equipment lifespans and reducing resource consumption. Siemens' AI platform analyzes sensor data from industrial equipment to predict failures before they occur, allowing for targeted maintenance that reduces downtime, energy use, and waste. This approach has reduced maintenance costs by 30%, while extending machine lifespans by up to 40%. For product design, AI is enabling more sustainable approaches through computational design tools. Companies like Airbus use generative design software that leverages machine learning to create aircraft components that are up to 45% lighter while maintaining structural integrity. Lighter components mean less fuel consumption over the aircraft's lifetime, a significant environmental benefit. In the fashion industry, notorious for its environmental footprint, AI is enabling more sustainable practices. H&M uses machine learning to analyze sales data and social media trends to better match production to actual demand, reducing overproduction and associated waste. Meanwhile, startups like Queen of Raw use blockchain and AI to create marketplaces for dead stock fabrics, materials that would otherwise end up in landfills. Even waste management is being transformed by AI capabilities. The company AMP Robotics has developed sorting robots with computer vision systems that can identify and separate recyclable materials from waste streams with twice the speed and accuracy of manual sorting. This technology makes recycling economically viable for materials that were previously too costly to recover. What's exciting about AI and business sustainability is that it often aligns environmental benefits with economic ones, notes sustainability consultant Mark Richardson. When companies can simultaneously reduce costs and environmental impacts, sustainability initiatives move from charity to strategic priority. Perhaps most promising is AI's role in enabling circular economy business models. The Finnish innovation fund Citra has developed AI systems that match waste outputs from one industry with potential inputs for another, creating industrial symbiosis networks that transform waste into resources. This approach has already created regional networks where dozens of companies exchange materials that would otherwise be discarded, reducing both extraction pressure and waste disposal. As we've seen throughout this exploration, artificial intelligence is becoming an invaluable ally in our fight against climate change and for a more sustainable future. From enhancing our understanding of climate systems to optimizing energy grids, from protecting biodiversity to reimagining urban environments, and from transforming business practices to enabling circular economies, AI applications are creating opportunities for environmental progress across virtually every sector. However, the green AI revolution is not without its challenges. The carbon footprint of training large AI models remains significant, with some estimates suggesting that training a single large language model can emit as much carbon as 5 cars over their entire lifetimes. Addressing AI's own environmental impact through more efficient algorithms, renewable-powered data centers, and carbon-aware computing will be essential for ensuring the technology delivers net positive environmental benefits. Equally important is ensuring that these powerful tools are accessible globally, not just to wealthy nations and corporations. Climate change affects vulnerable communities most severely, and AI solutions must be designed with equity and accessibility in mind. Open-source initiatives like ClimateNet, which provides publicly accessible climate datasets and models, represent promising steps in this direction. As we look to the future, perhaps the most transformative potential lies in AI systems that integrate across domains, connecting climate science insights with energy optimization, ecosystem protection with urban planning, and sustainable business practices with circular economy principles. These interconnected systems could enable holistic approaches to sustainability that transcend traditional silos. What's clear is that while AI offers powerful tools for sustainability, technology alone cannot solve the climate crisis. These innovations must be paired with bold policy measures, shifts in consumer behavior, and fundamental changes to our economic systems. AI can help implement these changes more effectively, but the will to transform our relationship with the planet must come from us. As we close this episode of AI Pulse Trends, I hope you've gained insight into how artificial intelligence is being harnessed for perhaps its most noble purpose, securing a livable planet for future generations. The ingenuity behind these applications reminds us that human creativity, amplified by computational power, offers reasons for hope, even in the face of our greatest environmental challenges. Thank you for joining us on this exploration of AI in climate change and sustainability. Until next time, this is AI Pulse Trends, keeping you at the forefront of the AI revolution that's reshaping our world. Remember to like, subscribe, and hit the notification bell to stay updated on our latest episodes exploring the cutting-edge applications of artificial intelligence. Share your thoughts in the comments below, and let us know which aspects of AI and sustainability you'd like us to explore in future episodes. Until next time, this is AI Pulse Trends, where we decode the future, one algorithm at a time.